Hi there, Mr. Arnold here for Hegarty Maths, and this is a video tutorial on the quadratic formula and the discriminant. And this is aimed at your core maths modules. Okay, so we would have come across the quadratic formula before, in particular at GCSE, and it basically states that if we have quadratics that have a general form, ax squared plus bx plus c equal to 0, then we can solve that quadratic by using this quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac over 2a. So we put these, we substitute these values a, b and c into the formula, and that will tell us the solutions to the equation, or the roots of the equation equal to 0. So what does the discriminant tell us? Well, the discriminant is this part here of the equation. I'll just highlight it, of the quadratic equation, or the quadratic formula. That's the discriminant, and it tells us about the roots of the equation, or the solutions of the equation. And what we find that is if b squared minus 4ac is greater than 0, then we're going to have two solutions, because when we work out the formula, we're going to have to add this this answer, and we're going to have to take it away. So we get two different solutions. Okay, so we get two real solutions. Two real solutions. However, if we find that b squared minus 4ac is equal to 0, then everything, we're going to have the square root of 0, which is 0, so we're going to add 0 and take away 0, which means there's actually only going to be one solution, or what they say is equal solutions. So the solutions are the same. One repeated solution, if you will. And then the third and final way it could happen is we could have b squared minus 4ac could be less than 0. And if that happens, if b squared minus 4ac is less than 0, then we're going to end up with a negative number underneath a square root sign, which means that there is no real solutions. In this instance, in the first one, that means it cuts the axis twice. It cuts the x-axis twice. The graph will cut x-axis twice. In this scenario, it touches the axis just once, or if you will, it cuts x-axis once, and in this one it doesn't cut the x-axis. Okay, so let's have a look at a few examples to see how this works. So suppose I have this quadratic here. Y equals x squared plus 5x minus 2, and I want to work out how many solutions it has. First thing I'm going to do is work out what a, b and c is. A equals 1, b equals 2, and c, not b equals 2, I don't know where I got that from. B equals 5 and c equals negative 2. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant at the end. And what I'm going to do is work out b squared minus 4ac which equals 5 squared minus 4 times a, which is 1, times c, which is negative 2. 5 squared is 25, and then negative 4 times 1 is negative 4, and negative 4 times negative 2 is positive 8. So we get an answer of 25 and 8, 33. So that's positive, it's greater than 0. 33 is greater than 0, so we get 2 roots or 2 solutions. 2 roots, which are your solutions. Okay, let's have a look at example 2 here. We've got y equals 4x squared plus 8x plus 4. So, a is going to be equal to 4. Let's use some different colours just to really highlight what's going on. B will equal 8, comes from here, and C will equal 4. So now let's do b squared minus 4ac. So we're checking the discriminant. Okay, so we get 8 squared minus 4 times a, which is 4, times c, which is 4. 8 squared is 64. Take away 4 times 4 is 16, and 16 times 4 is also 64. So we get an answer equal to 0, which means it has one root. 0 is equal to 0, and if we remember from back up here, yeah, b squared minus 4ac is equal to 0. That means we've got equal solutions, or equal roots. Equal solutions or roots. Now let me show you this really quickly using Desmos. So we got 4x squared plus 8x plus 4. Y equals 4x squared plus 8x plus 4. And you can see quite clearly here the graph just touches the x-axis at one point. So we say it's got equal solutions, and there it is there. Now if I was to go back and show you the other one just to prove to you that we're doing this correctly, x squared plus 5x minus 2. So let's change this. X squared plus 5x plus 2, and we can see x squared plus 5x minus 2, beg your pardon, minus 2. We can see that this graph has two solutions. It cuts the x-axis at 2 points there and there, and I could work these out by using the quadratic formula. Okay, let's do the third one. So example 3. Again, I'm going to write down a, b and c. A will equal 3, that's the coefficient of x squared. B will equal 4, coefficient of x, and c will equal 2. Okay, so we're going to work out b squared minus 4ac again. So b squared minus 4ac equals b squared is 4, so 4 squared, sorry, b is 4, 4 squared minus 4 times a, which is 3, times c, which is 2. 4 squared, 64. 4 times 3 is 12. 4 times 3 is 12. I don't know why I've written down 4 squared is 64. Maybe I'm not awake. 4 squared is 16 in this planet. Where was I? 4 times 3 is 12, and 12 times 2 is 24. So 16 subtract 24, which gives us an answer of -8. And negative 8 is less than 0, which means no roots or no solutions. What will that mean? It means that it doesn't cross the x-axis at any point. So let's check. 3x squared plus 4x plus 2. Let's see what it looks like. 3x squared plus 4x plus 2. And there we have it. There's our quadratic curve there. And we can see that it doesn't cross the x-axis at any point. So it has no solutions. And that's the power of the discriminant. It tells us about the number of solutions to a quadratic. Okay. Now we can sketch the quadratics as well using the discriminant and completing the square and various other pieces of information. So let's have a look at this first example here. Suppose I wanted to sketch this quadratic. The first thing I'm going to think about is the shape of the quadratic. I know it's going to look like a U or an N. It's going to be a U shape, or an N shape. And that is decided basically whether the x squared, the number in front of x squared, is positive or negative. It's going to look like a U if the x squared is positive, and it's going to look like an N if the x squared is negative. So this is going to look like a U. That's the first thing. Another thing I can do to help me work out some values of the quadratic is I can let x equal 0. If I let x equal 0, that tells me what the value of y is. So think about this. On this axis here, everywhere along this axis, x is equal to 0. And if I let x equal 0, that will tell me where the graph cuts the y-axis. So in this one, for example, when x is 0, the value of y is 2. And you can see quite clearly that this quadratic here cuts the axis at 2. So let's go back to this one. Let x equal 0, which implies that y will equal 7. That will be 0, and that will be 0, so y is equal to 7. So I know that the y-intercept is going to be the point 0, 7. That's the y-intercept. What else can I work out? Well, I can let x equal 0. I can let x equal 0 and work out where it crosses the... Sorry, let y equal 0 and then work out where it crosses the x-axis. But I'm not going to do that yet until I know if there are solutions or not. So I'm going to work out b squared minus 4ac to see how many solutions there are. So b squared minus 4ac will equal negative 2 squared minus 4 times a is 1 and c is 7. So let's work that out. Negative 2 squared is 4, so we get 4 minus 4 times 1 is 4 times 7 is 28 times 28, which will equal negative 24. So I know that this quadratic will not cross the y-axis because, or will not cross the x-axis because b squared minus 4ac is less than 0. So no roots, no solutions, no real roots, if you will. Okay, what else can I work out? Well, we can complete the square. Let's complete the square here and see what we can work out. So we've got y equals, and hopefully you've watched the video on completing the square, so we'll be able to manage this. I'm going to write an x in first. Negative, must be negative here. Half this coefficient, which gives me 1, and then square the brackets. When I expand this out, I'm going to get plus 1. I want to get rid of that. And then we've got the 7 at the end, plus 7. So tidying that up, we get y equals x minus 1 to be squared plus 6. So what will that tell me? Okay, if I was to let x equal 1, when x is 1, when x is 1, all of this part disappears. We get y equals 6. Yeah, if that's 1, this becomes 0, and 0 squared is 0, so we get 0 plus 6, y will equal 6. Now let me show you on the on Desmos exactly what I've just found. So let's put it in this form. Y equals x minus 1 all squared plus 6. X minus 1 all squared plus 6. And let's take all of this away, we don't want that. So there's our quadratic. We've already ascertained that we have no solution, so it won't cross the x-axis. But also I found another vital piece of information. I've got this, which is the minimum of the curve. If the curve has a U shape, then it must have a minimum point. If it's an N shape, it must have a maximum point. Well, we seem to have found the minimum point. When x is 1, y will be 6. So that's the beauty of completing the square. I now know the minimum point, 1, 6. So now I should be able to sketch this curve. I'm going to make a wee bit of space, and then I can sketch the curve. Let's just move this down for now. Move that guy down, and that one, and let's sketch it. So as I was saying, we know when x is 1, y is 6. That's the minimum point of the curve. So if I was asked to sketch it, this is what I do. Draw my axes like so, and that's x and that's y. Okay, now let's just put in the information we know. We know that when x is 0, y is 7, so I know that I can put that in, 0, 7. I know that the curve is going to be a U-shaped curve. It's going to be a U-shaped curve. I know that there's no roots, so it's not going to cross this axis here. In fact, let's move this guy down just so we have a bit more space. Okay, it's not going to cross the x-axis at any point. And I also know that the minimum point is when x is 1 and y is 6. So when x is 1 and y is 6, so say somewhere around here. I'm not liking all this black colour. Let's change it. So we've got the point 0, 7, and we know when x is 1, y is 6, so we can put that there if you will. 1, 6 is the minimum. So the curve is going to come down like so. It's going to touch, that's our minimum point, and then it's going to go off in this direction, a U shape. Not the best diagram in the world. It is just a sketch. Right, let's have a look at another one. And let's move example 3 to the right. Let's move this over here. We can come back to you in a minute. Okay, let's have a look at example 2. You might want to have a go yourself. Pause the video, maybe give it a go. Okay, let's start by considering the shape. The shape of our quadratic is U-shaped. How do I know that? The shape is a U-shape because the coefficient of x squared is positive. If that's positive, it must look like a U. If it's negative, it's going to look like an N. So the shape is a U. That's the first thing. The second thing I'm going to do is I'm going to let x equal 0. When I let x equal 0, that gives me the y-intercept. So let x equal 0, that implies that's 0, that's 0. So we get y is equal to minus 3. Okay, so we have a point 0, minus 3 is our y-intercept. Y-intercept. Okay, let's now consider the number of roots. So does this quadratic cross the x-axis? So we're going to check the discriminant. B squared minus 4ac equals 2 squared minus 4 times a, which is 1, times c, which is negative 3, which equals 4 minus 4, or negative 4 times 1 is negative 4, times negative 3 is going to be positive 12. So you get 4 plus 12 equals 16. So b squared minus 4ac is 16, which is positive. So let's write this over here. 16 is greater than 0. So we get 2 roots, or 2 solutions. Now let's work out what those solutions are. Those solutions must be when x equals 0. Oh, sorry, when y equals 0. So we're going to let y equal 0. That implies we get our quadratic x squared plus 2x take away 3 is equal to 0. Now can we solve this using a traditional method? Let's see. Yeah, we should be okay. We should be okay to solve this. So think of 2 factors that multiply to give negative 3, but add to give 2, x and x, and then it's going to be plus 3, take away 1, 3, take away 1 is 2, and 3 times minus 1 is minus 3. So that means x equals negative 3, or x equals 1. So we've solved that now. So now I have the points where it crosses the x-axis in 2 places. And those points are when x is negative 3, y will be 0. And when x is 1, y will also be 0. So now I might be able to sketch it, but I'm gonna go for one more piece of information. In order to do that, I'm going to need more space. So example 3 and example 4 have been shifted. Let's move you down to there for now. Right, so the last thing I'm going to do is complete the square. So we've got, let's complete the square in green. We had y equals x squared plus 2x minus 3. So like before, focus on this guy here. We get y equals, open the bracket, x, and then half this coefficient, which is 1. Square that. When I expand this out, I'm going to get a plus 1 at the end. I don't want it, get rid of it. And then we've got the minus 3 to take into account. So that equals x plus 1 squared minus 4. Now I've got another piece of information. Alright, if you remember from the last example, if x is going to be negative 1, when x is minus 1, y will be negative 4. And that's the minimum point of our graph. This is the minimum point. The minimum point. So let's sketch it. So I'm going to draw some nice axes like this. 1, 2, 3 and 4. This is our x-axis, this is our y-axis. Okay, so from the top we know that the shape is a U, and I know that the y-intercept is 0, minus 3. So the y-intercept is 0, minus 3. That's our y-intercept there. In fact, let's not do it in that colour. Let's go for blue. 0, minus 3. Now you'll notice I haven't done a scale. It is just a sketch, so it's okay to do it like this. Just make sure that you label all important points. That's one of them, 0, minus 3. I know that the roots, or where it crosses the x-axis, are these points here. Negative 3, 0 and 1, 0. So negative 3, 0, negative 3 and 0, and 1, 0. And it's going to be a U-shaped graph like this. And then the other thing I know is that the minimum is at minus 1, minus 4. Minus 1, minus 4. I'm just trying to move this over to here. So minus 1, minus 4, which would be around about here. That's our minimum point. So the graph will come down like this. It comes to the minimum point, and then through the intercept, and then up through the other route, and off she goes. And that's a nice sketch. Well, not a nice sketch, but hopefully you get the idea. Right, that's number 2 done. Let's bring example 3 back from the dead. Example 3, 1, 2, okay. Where did he go? Here we go. Right, come with us this time. Here we go. Lovely. So example 3. Example 4, we'll see you in a minute. I never thought I would need so much space, but no, whenever. We'll keep going. Alright. Right, first of all, let's consider the shape of the graph. The shape is a U shape because this is positive. B squared minus 4AC is going to equal minus 4 squared minus 4 times A, which is 3, times C, which is 2, which gives us 16, minus 4 times 3 is 12, 12 times 2 is 24. So this is negative 8. So this has no solutions. No solutions, or no roots. No real solutions. There are complex numbers, but you don't need to worry about them. No roots. No real roots. What else do we need to get? We need to get an intercept. Let's get the y-intercept. Y-intercept. Y-intercept is... We get that by letting x equal 0, so that becomes 0, and all of that becomes 0. So we get 0 and 2. There's not going to be any x-intercept because there's no roots. So let's get the minimum from completing the square. So let's write this down. Y equals 3x squared minus 4x plus 2. Right, we're going to have to complete the square here. I know I'm going to need more space for this for sure. Shifting you down. Okay. Okay, remember when we complete the square, we need the x squared part to be 1. So I'm going to factor out this 3. So factoring out the 3, I get x squared minus 4 over 3 x, and then we've got the 2 at the end. Now what I'm going to worry about is this part that I'll underline in green. This is the only part I'm going to worry about for now. So leave the rest alone, leave the 3 outside, and say that, let's leave that 2 there. Let's complete the square for the part in green. So I'm going to open up a pair of brackets, x, and I need to half this coefficient here. It's going to be negative half the coefficient. We get 4 over 6, 4 over 6, which is 2 over 3. 4 over 6, which is 2 over 3, 2 over 3. And when I square that, when I square this part, I'm going to get a positive 4 over 9, which I don't want. So take away 4 over 9. Alright, lovely. Next thing I'm going to do is reintroduce this 3. So 3 times this first part in green here, we get 3 times x minus 2 over 3 squared, and then 3 times negative 4 over 9 is negative 12 over 9, right? It's going to be negative 12 over 9. When I simplify this guy down, I'm going to get 4 over 3 minus 4 over 3, and then add the 2. 3 times x minus 2 over 3 to be squared. Let me see, this is going to be 6 over 3, so we're going to get a total of plus 2 over 3. 4 over 3 minus 4 over 3 plus 6 over 3 is 2 over 3. Alright, lovely. And all the way down, y, 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 and y. So the minimum now, the minimum value, I just need a number to make this part 0, and that would be 2 over 3. So the minimum is going to be when x is 2 over 3, y will be 2 over 3. So now we should be in a good position to sketch our graph. We'll use purple this time. I actually think, let's not put it there. Poor example 4 is getting moved further and further down. Oh well, we'll get to you in a moment. Okay, so quick sketch. Now we remember that it had no roots, so it's not going to cross the x-axis. You don't need to go down too far. X and y. Alright, so what do we know? Alright, we know that the minimum is going to be at 2 over 3, 2 over 3. We can say that that's here. That's the minimum. 2 over 3 and 2 over 3. What else do we know? We know that it's a U-shape. I know that it's got no roots, so it's not going to cross the x-axis, and I know that the y-intercept, or where it crosses the y-axis, is 0, 2. So 0, 2, 0, 2. So now I can sketch the graph. That's the minimum point. That's the lowest point on the graph. So something like this, off up to infinity, and like this. It shouldn't look like a V, but it's difficult for me to draw it using this tablet. So something like that. Okay. Now let me show you, just to be 100% sure that we've done this correctly. We had 3x squared minus 4x plus 2. Let's go back to here. Y equals 3x squared minus 4x. I think it was plus 2. It was indeed. Plus 2. Okay. And look at that. There we go. 0, 2 is our y-intercept, and 0.67, which is 2 over 3. It's rounded it. And the same for this one, that's 2 over 3. So we can see we've got this absolutely spot on. Our sketch is good. I can't stress enough, guys, how good that Desmos calculator is. So I highly recommend getting onto that and playing around and experimenting and exploring different functions and graphs and stuff like that. Really is good. Alright, final one, here we go. Y equals minus 2x squared plus 8x plus 15. Right, first thing we're going to do, consider this shape. Shape has an E, last time I checked. Shape. The shape is an n-shaped graph because the coefficient of x squared is negative. So it's going to look like this, something like this. That's the shape. Next thing is b squared minus 4ac. Oh no, let's do the y-intercept. 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 And the y-intercept comes by letting x equal 0. Okay, so x equals 0 gives us all of this is 0, that's 0, so we get y equals negative 15. So the y-intercept is 0 and negative 15. Let's do the discriminant. So let's see how many solutions there are. Let's do b squared. Let's change colour as well. I'm getting bored of blue. B squared minus 4ac. B squared minus 4ac. So we get 8 squared minus 4 times a, which is negative 2, times c, which is negative 15. Okay, 8 squared is 64. Minus 4 times minus 2 is 8, and then 8 times negative 15. Well, I know 4 15s are 60. That means 8 of them must be 120. Minus 1, 2, 0. You know, I'm going to make a very, very quick change to this problem because I don't want another one that has no solutions. I'm going to change this to a plus. Let's make that plus, which means that that is positive, which means that's positive, and which makes that positive, which will make this positive. So we get x equals 64 and 120, which is going to give me 184. And 184 is greater than 0. 184 is greater than 0. So we get 2 solutions. Okay, 2 solutions. Now this is going to be tricky, but we'll see how we go. Right, next thing, I'm going to work out the maximum point. Okay, it's an n-shaped graph. It looks like this, so we're going to have a maximum point somewhere. So let's work that out. The max. The max comes from completing the square. So what had we got? We had negative 2, y equals negative 2 x squared plus 8x plus 15. So y equals negative 2. I'm factoring out. I want x squared. Can't be plus. This can't be a plus. I factored out negative 2. So this must be negative as well. For x plus 15. Okay, negative 2 x squared minus 4x plus 15. And all I'm going to worry about for now is this guy here. Complete the square with this, leave the rest the same. So y equals, leave the negative 2 there, open the brackets, leave ourselves some space. The 15 is at the end. Alright, so I'm going to, for this, completing the square here, x, this is negative, so this is going to be negative. Half this coefficient, we get 2, and put the squared sign outside. When I expand this, I'm going to end up with negative 2 squared, which is positive 4. I don't want that, so take away 4. Now we're going to introduce this negative 2 back in, so multiply it out. minus 2 times this, minus 2 times x minus 2 squared, minus 2 times minus 4 is minus or plus 8, and then we've got the 15, plus 15. Tidying it up, minus 2, x minus 2 squared, and then 8 and 15, 23. So that's y, which means the maximum, should be able to see the maximum now hopefully. The maximum comes when this part disappears, and the only number to make this disappear would be when x is 2. So the maximum is going to be when x is 2. Yeah, if I put a 2 in here, this becomes 0, 0 squared is 0, and 0 times minus 2 is 0. When x is 2, y will be 23. So that's the maximum. And now I need to get these roots. The roots come from when y equals 0. Roots when y equals 0. And because I've completed the square, I'm actually going to use this to get my roots rather than going back and using the quadratic formula. So substitute y equal to 0 in here. We get 0 equals negative 2 times x minus 2 squared plus 23. Okay, take 23 off both sides. So I'm going to rewrite it the other way. Negative 2 times x minus 2 squared is equal to negative 23. Divide both sides by negative 2. X minus 2 squared equals negative 23 over 2, which is going to give me 11.5. 11.5. And then finally, I'm going to take the square root of both sides. So x minus 2 equals, remember when we take square roots, we've got positive and negative answers. So plus or minus square root of 11.5, which means x equals adding 2 to both sides. So we get 2 plus root 11.5, or 2 minus root 11.5. Right, bit of a long-winded one, but we got there in the end. Now we got to draw our sketch. Okay, so we've ascertained that it's an N-shaped graph. I'm going to do the x-axis a little bit higher. So just okay, we've got x and y. Now it's an N-shaped graph. The y-intercept, let's go with the y-intercept first of all. The y-intercept is 0, 15. So say here 0, 15 is our y-intercept. The x-intercepts are at 2 plus 11.5, square root of 11.5. Let me see, square root of 9 is 3, square root of 16 is 4, so it's between 3 and 4. Between 3 and 4, plus the 2 is about, say, 5, so somewhere here. And this guy here, 2, take away a number that's between 3 and 4, so he's got to be over here somewhere. So this is 2 plus root 11.5. Once again, root 9 is 3, root 16 is 4, so this is going to be something between 3 and 4. When I add 2 to it, it's going to be around about 5, something between 5 and 6. Here, this is something between 3 and 4. When I take it away from 2, it's going to be negative, so it's going to be over here. This is 2 minus root 11.5. I made a terrible mistake here with this. I forgot to put the y coordinate. Right, so I'll put it in a moment. The maximum, I did the same here, the maximum we've worked out, which was 2 and 23. So the maximum is somewhere around here, 2 and 23. And we've already said that this is when x is 0, y is 2 minus root 11.5, and this is when x is 0, y is 2 plus root, and I have these backwards as well. What am I doing? My God. One there, one there. When x is 2 minus root 11.5, y will be 0, and when x is 2 plus root 11.5, y will be 0. And then if we were to sketch it, try and make it look like a U, something like this, and it'll come down like that. Okay, finally we got there in the end. A pretty long-winded question, lots of examples there, but hopefully you get the idea. We'll be back again with another video soon. All the best with the revision, and we'll talk to you again sometime.